It's 4 o'clock in Germany. Hello, world. Hydrogen moves the people. Hydrogen moves the world. And for sure, hydrogen moves fuel cell modules and also the applications around. Welcome to the Hydrogen Moves webinar today in cooperation with the Next Mobility Accelerator Consortium. Dear participants, give us in the chat from where you are joining, and then we can see how many people and from where you are joining, and you are today here with us. I can see US, Paraguay, Ukraine, Sri Lanka, Denmark, Costa Rica, Romania, Berlin. So hi there, from north to south, from east to west. Georg Zembacher is waiting in the background, and after my short introduction, for sure, he will come here on stage and give you the real content of today. And the real content today is with Toyota TSUSHO NEXTY Electronics Europe, and the topic hydrogen moves the Toyota fuel cell module. You will learn a lot. I'm pretty sure. I had a short chat at the very start of the webinar in the lobby, so to say, and I can tell you, it's good that you are here. There you go. Your host, Hydrogen Moves. Perhaps some of you have recognized that I've changed jobs. I'm the same Silke as always. Hi, nice to meet you. Nice to get into contact with you again. But the company has changed. Hydrogen Moves is now my own one. And with the team of Elizabeth and Irma, we are happy to give you the content as we did in the last years, and also bring you the best marketing that you need when it comes to hydrogen. And we're in the middle of hydrogen acceleration, and we listen to your needs, wishes, and show you precisely how you can make your hydrogen market happen. Visit the homepage and register for the newsletter, and for sure also follow us on LinkedIn and Twitter, not only for the company, but also you can follow myself and we can exchange there. A lot of news will come in the next days, weeks, and for sure months and years. Short outside to next week on August 4, same time, 4 o'clock German time, we will have another webinar that the Next Mobility Accelerator Consortium brought to the people that were on site on June 3 in Bavaria during the PIN event together with Shell. And Carsten Wilbrand will come on stage with an English webinar also next week for you. Sustainable heavy-duty transport from an energy system perspective. This will be really inspiring also next week. I've heard it in June, and I recommend to follow up and to forward it to your colleagues, the link, and also to register. There you go. Now I would like to change presentations, stop my presentation and start the one for Georg Zembacher. There you go. Here he is, the real star of today. I'm just your frame, dear Georg. I'm so happy to have you here, and I'm pretty sure our participants today will get a lot of content, and for sure after you are ready with the presentation, dear audience, feel free to ask him everything you want to know in our Q&A session, as always. Dear Georg, now the virtual stage is yours. Hi and welcome.
Hello, thank you for your kind introduction. Hello, everybody. Thank you, Silke. Thank you for all the consortium members that we can be here. And I can show you our activities and our contribution to the hydrogen world. So probably first of all, where we are coming from. So as you know, Toyota Motors as a brilliant brand somehow we are part of it, because as you have recognized in our company name, let's say we are starting like that. But I wanted to give you a very short introduction where we are organized. So where is our home around the Toyota Motors? So as you can see, in the center of the presentation is the big Toyota Motors, let's say the backbone of our, let's say, corporations. And around that, you see a lot of companies, they belong to more or less shares, let's say, to Toyota Motors. As well, my mother company, the TSUSHO House. TSUSHO House is basically, let's say, a very strong, let's say, trading house, traditionally, let's say, importing, exporting goods for the car manufacturing, and then, let's say, to distribute the products as well worldwide. We have a lot of divisions inside. We have chemical focus. We have as well other distribution channels. And I'm lucky to be in the subdivision for electronics. This is, let's say, the very exorbitant long name for the company itself, but a very nice place to be. So we are the core electronics and, let's say, semiconductor trading house part. But in the last years, we changed a lot in our activities and as well our contribution to the hydrogen world. Now, if you are thinking how we are typically operate, so traditionally we are semiconductor trading house as well, and integration work to it. So we are very used to integrate very small things to very big things. And what I have done in 2020, as all this, let's say, started for us internally, to find out how even more complex products, integrated products, could be, let's say, put into a vehicle in a stationary applications. And I try to play with different technologies, how to connect them newly to probably other products, which creates more value to the customers as they have today. And I'm a little bit a lucky guy, because I can cherry pick a little bit, let's say, what is really cool, let's say, what is very hot, and sometimes which is not hot now, but it could become very hot in the future. And I'm very carefully taking care, not about the technology, but as well about the business model behind it, because it needs to be sustainable, as all our company contribution is, let's say, to the world. We are looking for the long run. Now, only a short view of, let's say, our semiconductor products. So I don't want to sell you anything out of that. We are basically, let's say, very, very strong to our group companies. We are keeping, let's say, a very, very good stock of them and keeping our operations running. Now, to give it a bigger picture, what is Toyota or Toyota Group companies are doing, and what is our contribution basically to that? So we are following, let's say, the Toyota Environmental Challenge for 2050, where we have, let's say, to go to zero CO2. So this is, let's say, our very clear target, and CO2 is our enemy. So this is basically what we are focusing on. Every tool and every solution which helps to achieve this target is highly welcome. And this is the reason as well why we are not thinking only in one propulsion or one drivetrain technology, because I will come later to that, but I think that in many markets we have different solutions, or let's say different people, we have to have different solutions. So we cannot have one technology solves all. So for that purpose, we have, let's say, the mixture in between the different propulsion systems, which in the sum plus, let's say, everything which is coming from the manufacturing, coming from the water usage, let's say, and what about the environmental effects, but as well we have a very strong focus as well what happens in the society with our system, how we contribute to the mobility in, let's say, overall. And then I like to show always my foxes because, nature created a diversification, because for every circumstances you need to have the proper, let's say, color of the hair, shape and size of let's say of the body of the animals, and they are very highly adjusted to the circumstances. And this is exactly the strategy and the philosophy, let's say, for all the different powertrains. So if we are thinking of, let's say, different electrification concepts, they all fit to the bigger picture where we think it's somehow everything is a hybrid. So as you know, this year we will have 25 years anniversary for the first hybrid vehicle. But everything follows the same concept, that we are very modular and we can, let's say, exchange all the parts for it around it. So we have the full hybrid where the ICE is still in. We have the battery electric where, let's say, Toyota Motors presented this year a very nice product, and it is a lot in the pipeline what we are working on. We have the plug-in hybrid, and for sure on the right bottom you have the fuel cell hybrid. We are always hybrid. There's always a battery inside. So for us, it is not a competition in between the battery system and the hybrid system. We are always let's say, a range extender. We are always a product which extends, let's say, the performance, or on the other hand, compensates, let's say, the weaknesses of the battery system, even on the very long life, let's say, usage. Then if you think about how long Toyota Motors is working on the hydrogen, it's really long history. And this is a continuous, let's say, work and continuous fight to place the product really in production. So it was always the target to bring it to the people. So even, we get some painful developments behind, but we continuously worked on it. And let's say we from NEXTY contributed as well from the electronics and semiconductor side. Now, if you take the jump in between the first generation Mirai and now the second generation Mirai was really significant and vast. So this change and this step was really a game changer, because now we not only have the production capability started from the first generation and a huge fleet experience, the good and the bad fleet experience, and on the other hand, we could as well invest a lot of money in the efficiency of this product and the durability of the product, so it becomes a very cool product overall, which I'm always surprised to see if I see a benchmark data where we are. So the idea of the module started, let's say, with the thinking, okay, how we can scale this product, how to open the technology as well to other, let's say, players in the market, without hiding the technology. We wanted to always share the technology. So we were always very focusing on let's say, in the society support and positive impact to that. So the thinking was, okay, the Mirai, it's a beautiful car, very nicely done. We have separated all the components because of weight distribution or noise emissions and that kind of stuff. So in the passenger car, you think completely differently how, let's say, the module needs to be placed or created, because for the module, for us, it's not only the stack. So we are thinking the module itself is a combined system, which is, let's say, perfectly adjusted to itself, and let's say follows a very efficient operation for that. So we took now the Mirai 2 product and then basically use the same components. There is no difference in between the Mirai 2 and the module products. So as they are distributed, let's say, in the vehicle, each of those components, they get repackaged So not only physically put together, but as well electrically connected on the hydrogen gas path. We connected as well the air path, and all the, let's say, the system is packaged in two different shapes and sizes. So the main idea was for the Type 1 that most of the vehicles are designed in a very specific way today, where the combustion engine needs to fit in. So the Type 1 is basically, we call it vertical type. It's mainly replaces an an ICE, so an internal combustion engine. This is, let's say, the compartment size typically what you have. So an average one, not perfectly fits well everything, but especially for heavy duty or for bigger applications, perfectly fits in as a unit, so you can put it as one box. The Type 2, we called it a horizontal type, which is on the bottom right. This is, let's say, perfectly follows the shapes of a diesel tank, typically hanged on the, let's say, on the frame of a truck, left or right. And it follows exactly the same, let's say, shape and size definitions, which is quite easy to integrate in a specific system as well, outside or on top or somewhere in the backside of the specific applications. Or on the other side, if you go for a stationary application, you can use it, let's say, as a beautiful, you can put it in a rig, and you can maintain it as well from the side or from the top in a very simple way. So these are, let's say, the boxes, what we use typically for marketing. This is not how they really look like. So I wanted to show you in 2 pages how they really look like, so you can see what is as well a little bit inside and how they are built up, so you can see all the stuff. So probably now a little bit on the specification shortly. So as we see, we have the, let's say, the Type 1, the vertical and the horizontal. From the shape and size, they differ, but in the technical specification, they're absolutely the same. What is different is the netto output electrical power. We have 2 versions for both, 60 and 80. We define it like this. So it's like this. We know that most of our customers would like to have 100, 120 kilowatt and so on, but that was the definition, how to use it in between passenger car, medium truck, heavy duty truck, how to multiply it. So the beauty of this system is that you can use many in parallel and they don't know each other. So basically you're completely independent of the power output. You don't need to consider how to connect the high voltage passes, because they are prepared that they can, let's say, band and collaborate, let's say, on that sense, but they don't need to be connected from the controller side. So you give a certain demand to them and they realize it. That's it. The voltage range is quite wide. And it is super dynamic. As you can imagine, for the passenger car, we have a super small battery for the hybrid battery buffering. And most of the dynamics come from the fuel cell itself. So which requires a certain range, but in let's say the range gives us a fantastic dynamic. But if you increase the range for the voltage, then you need to, let's say, limit yourself in the performance, in the dynamics. So we have chosen to define it like this. So it works in between 400 to 750 volt. The full range we can cover. So, but not higher. What is as well very interesting, I think, is the cold start capability. This is quite unique because we can start from minus 30 degrees Celsius in a very short time. So it is, compared to all the other systems, it is a very, very, very short start, less than 2 minutes. Depends on the, let's say, configuration of the system, usage of the different battery types, but it is a very short start performance. Let's say from the hydrogen pressure, we are quite easy to connect. So the pressure in the tank, you can use what you want until you deliver some hydrogen. We can fulfill the wish. We give you the electrical power rate, let's say, given out of the system. What is as well, let's say, always the challenge for the PEM fuel cell module. This is equally what kind of supplier you are taking and what technology supplier you have. We have a quite narrow cooling system temperature range. So as we are thinking of integrating the system, let's say this module, this power generator, let's say, to a different vehicle or station application, the cooling system design is very, very critical. So as we are operating like this, that we are, let's say, only reviewing what you're doing. So our know-how is based on, let's say, on the simulation values, on the field data and so on. But the idea is that we will not do the integration for you. So there are different concepts how it could be integrated, but we have decided to follow the approach that we teach you how to fish, but you need to fish. And we are checking if you have fished right, because there are so many ways how you can fish. And let's say in terms of integration, we recognize now that every company has its own approach. Which point they start. Somebody starts with a cooling system, somebody starts with the electrical integration, high voltage, somebody starts from the low voltage, somebody starts from different type of maintenance concept, and every company has its own style. So we don't limit, let's say, our customers and partner corporations. They can choose the path what they want, and we are basically guiding them, giving them the help that they can really integrate it in a proper way. So where the cooling system is one of the most critical parts. And this is really tricky because most of the traditional vehicle designs, as you take for a diesel system or other let's say propulsion systems, the point is the cooling is not that big what we need for a PEM fuel cell module. What is solvable? They are very clever engineers, come to very cool ideas, and everybody solved that in a different way, but there are very nice solutions to that. You will see more and more. So probably you have seen as well the Paul Nutzfahrzeuge truck, which is, I think, a very, very cool design. But on the other hand, you see as well the nice packaging to it. And they found as well a solution how the cooling system can be integrated. Then let's say these are the hydrogen consumption values. And if you think this is the full power, so this is the full netto 80 kilowatt we produce, this is really what you get on the high voltage connector. We produce more electrical power with the fuel cell itself, with the stack itself, because we use the power, let's say, for the water circulation pumps. We use it for the air compressor. We use it as well for the low temperature water pumps. So all the pumps and all the supporting aggregates, what you need, are really fed by the stack itself. So the stack, it has basically more power, but we use first, let's say, to run the system in a proper condition, and then the 80 kilowatt is what you get as a netto real output, measurable output, even after very long time of usage. If you think about the efficiency, it is, let's say, as you have every system, if you are working in a very top, let's say, end of its power, let's say, output, the efficiency, you have to have, let's say, a certain, you need to accept that you have some conversion losses or some thermal losses whatsoever. But we are, let's say, in around of 45 to 50% of output efficiency. If you can reduce the output power below than, let's say, 40 kilowatt, then you will end up nearly or more than, let's say, 55 to 60% efficiency, which is quite outstanding. So, but the package itself, as it is married so closely together, so the fusion is so cleverly done in between the component, that the overall efficiency is very nice, and it has a very low, let's say, hydrogen consumption because of that. Yeah. So these are this is the real thing. So if you see one, then you can this is the animal what we are talking about. This is the module, how it is integrated in a frame. This is a really heavy frame. So this is not only for decoration purpose or keep the parts together. It's a really heavy frame because it gives you as well the possibility to hang it from the side to some frame, or you can put it somewhere, you can hang it up, and it gives you a lot of, let's say, possibility for the mounting. In terms of integration, you see the high voltage, everything connected to it. You see all the pipes, wires, everything is inside. It comes as well with the high voltage DC-DC converter already, and it is already inside this frame, which some of the fuel cell modules what you can get on the market there, you need to organize yourself a third source whatsoever for it. Here it is inside, already integrated. The diagnostic system is connected to it. All the safety stuff is in. So we have designed it that it is fulfills the ISO 26262. This is everything documented. We are interacting with the vehicle. So it's not like that it's for itself can work in that sense. So we specified what is needed, what sensor information we need from the hydrogen leakage whatsoever. And then we are, let's say, reacting accordingly. So this is very well designed in terms of safety. And let's say the full OBD onboard diagnostics we have. So you can finger point to the arrows. Basically, it's an automotive part. Which is now, let's say, took out of a vehicle, but contains all the features what a passenger car or a truck electrical system would have for itself. And as you see, we have all the connectors on one side. So it is, let's say, put together on one end, which gives, let's say, to our customers and partner corporations to install it very quickly. So the time to market is very short. They don't need to check some new, let's say, to turn the screw somewhere. They can connect. They check, let's say, if everything works fine, and let's use it. So the idea is, let's say, to make as quick as possible usable for our customers. And yeah, very important thing comes with it. At the beginning, we didn't consider, but we found out that there are no connectors in the market available. So we are giving as well the connectors with it. You can order it through us, that you customize your wiring harness, whatsoever your cables. We give the interface specification that you can connect your pipes and so on. So we give every information what is necessary for the integration. And we give very strong and very good recommendations how to use it, not to shorten the useful life. So in that sense, we give, I think, a lot of experience and a lot of know-how to our integration companies. They can make a very, very good, very reliable product out of it. So we do everything, let's say, that the customer has the same quality in the overall brand new product, which basically is not a Toyota car anymore, not a Toyota truck anymore, but this part of the technology fulfills the promise, fulfills the Toyota quality. So we are very proud that we can really offer this as well outside of the Toyota Group company. So I think with the integration of Pepper Motion towards the Nutzfahrzeuge, it is a brilliant match how it could be shown that, let's say, how a complete different product can be built out of it with our help and support. And then, yeah, we have as well other things which are quite interesting to know, that we have identified beyond the module that we have a fantastic, let's say, source for every kind of high pressure device, and we have the complete, let's say, component sets available in-house, and we are as well very open to share this. So everything what is in the mirror, you can basically nearly everything you can have, but it has very unique strong points. which it's very interesting to know it for let's say for very specific niches, where you have to have a very high, let's say, cycle of refillings, which are beyond the standardized one. So we are outperforming by multiple times refilling the typical standards. Or you have a certain quality or a certain, let's say, temperature treatment, let's say, on the connectors, that kind of stuff, which is not the standard. So we made this product basically for a very, very long time, very, very long useful life. And sometimes we discovered it would make sense for a firefighter truck or whatsoever, where, let's say, this specific product specification is perfectly fits in. In the mass market, we could provide, but as of now, I don't know if somebody know it that we can supply it. So probably after this workshop, we will have more business opportunity for that, but so far probably nobody knows it. So and it has a certain variety, what you can identify, let's say, the specific diameters, and we basically make it longer. Yeah. So this is how, let's say, the volume or the kilogram what we are put in will, let's say, change. What's probably as well new for you, if you see this table, it is definitely outside of the Mirai storage capacity. So we are doing other things as well, which are for complete different applications. So we use the same tool, the same processes, the same quality to make tanks as well for, let's say, complete different applications. And I wanted to show you as well a complete different perspective, which in terms of, let's say, as innovation manager, I discover more and more that this is something what I don't hear that much, the digital connection in between, let's say, the asset as a vehicle, or the tank of the vehicle, the usage, the track, what you need to ride, let's say the payload combination to it, the fuel station connection to it, and then for some areas, the fuel station with the hydrogen production is to a certain level closed. But if you go for a fleet operation, you cannot compensate it with a huge fuel station. You cannot compensate it with a huge buffer, because it adds a lot of, let's say, cost to keep this hydrogen somewhere. You need to store it, you need to cool it, you need to transport it, and everything what you add on this buffer, it creates a higher hydrogen price for the end customer. And what we have, basically, what I discovered is that, as you know, the just-in-time, just-in-sequence thinking and philosophy, we have a lot of software solution for that. And I turned it that way that we can now estimate as digital twin, let's say, the vehicle usage. So far it was always focused on diesel vehicles whatsoever, but now already we can very accurately prognose for battery electric vehicles or hybrid vehicles what happens with the fuel consumption, what happens with the usage, what is the track, what you need to go on, let's say, in real time. And on the other hand, where to charge, what is the charging sequence. So for the vehicle, if you operate it as a public transportation planner, or you are, let's say, a fleet operation planner, you have to know where to charge. And if you think about hydrogen, it's even more critical, because you have to make sure that you are coming with the right truck, with the emptiest truck, let's say, to the fuel station in the right sequence as the fuel station is ready for you. Yeah. Or on the other hand, you need to request when the fuel station shall be perfectly ready for you, that you can maintain your operation. So it goes in both directions. Yeah. So the fuel station can say, hey, come on, you have to come in, home everybody in. refill it. Now we have the best price for it, we have the best pressure for it, everybody come. Or on the other way around, you can make a pull system out of it. I need something, and then you have the next sequence, you are the emptiest one, you come in, and then you are refilled on that. On the other hand, we can turn it as well even further, because this virtual fleet, what we can build up, it's fantastic for simulation purposes. So if you imagine, if you have one, let's say, hydrogen vehicle, you are happy. You have no problems, because the fuel station, typically, it's over-dimensioned compared to your truck, compared to your vehicle whatsoever. But if you have 1,000, or if you have 10,000, now you have a problem. You have to understand how the system will work. Can it really sustainable work, or you destroy one of the assets, or you cannot fulfill your operation? So you have to transport a volume. You cannot say, hey, today I don't have a refilling time, I cannot do the job. It's not acceptable. You have to keep it running. And for that purpose, we can do as well the simulation in that way, that we says, okay, what is the typical volume? What are the typical routes? What is the topography of the region? How are the drivers using it? And what energy fits to it? And where the fuel station needs to be. On the other hand, where needs to be the hub. Probably the hubs are not sitting in a proper position, even if for diesel was cool and nice location, but now you need to turn the complete world around, the energy flows. And I think as the energies becomes even more expensive, we will have more turning towards the cheaper energy sources and design like this. So I wanted to give you a glimpse as well what we are working on. And this is, let's say, a real-time system. So you have to make really acting on the current situation on the road, because traffic jam whatsoever. So you can go in very, very low details using, this is a fleet operating system what we have in Southeast Asia already running with more than 150,000 vehicles. What we are using there for different logistic or service providers, which are connected to our system. For me, it was as well very new to understand how big these platforms are and what kind of experience we can gain out of it, let's say, for the hydrogen world. So here I slowly wanted to stop explaining what we are doing and how we are contributing to it. I hope that you have a lot of questions for me, which I would be very, very happy to answer.
There you go. Dear Georg, thank you very much. And I think we understood quite well, and we saw some really deep dive and interesting charts. And I now will go to the Q&A section and let the QR code standing here so that you can easily get in contact with Georg. And I do have a question from Bernhard Albrecht. Considering worldwide customer interest in the stack modules, where is the production plant or the plants located?
So far, we are using the Japanese manufacturing location, where the Mirai is nearby manufactured or produced. This is because of, let's say, nobody expected that let's say, we will have such an interest in so short time. And there are a lot of discussions how this manufacturing could be scaled worldwide, what to do with North America, what to do with Europe. So there's a lot of discussion inside the group companies how to realize that. Yeah, but basically we are shipping everything out of Japan, which is in terms of currencies now a good time, because we make price reduction without negotiations. And on the other hand, let's say we can fulfill our promise to deliver in 4 months. So if you order here in Germany or in European mainland, latest in 4 months, you have it on your location, on your wish address in Europe. So this basically we don't feel it. as it is produced in Japan. I would say it's even more an advantage because this is not affected by this kind of supply chain turbulences from the others. Yeah.
There you go. Another one from Felix Kleinheinz. I will broadcast it to the room. There you go. What is the main difference in terms of lifetime requirements between light vehicle and heavy duty stack? Do you use a light vehicle stack also for heavy duty?
If you use multiple ones, it's possible. But there you have typically a physical limitation, a packaging problem. Because I think for most of the heavy duty applications, you have a different cabin design. So you don't have the space. So there is a natural limitation to it. You cannot put 3 inside. 2, it's reasonable, but to put, let's say, 3 inside, it will be quite hard. In terms of the usage itself, yes, the operation cycle has a huge impact on the lifetime. So basically, you have to think of we have the worst case driving cycle for the Mirai, where we have this, I think, 12 kilowatt hour small buffer battery, which is basically nothing, and where all the dynamic needs to come from the fuel cell. If you are considering a medium duty or light duty or whatsoever application where the fuel cell module becomes a range extender, there we don't have this severe dynamic operations for that. That means, it's very similar if an elderly gentleman drives a car, let's say very slow, very, very low dynamic, driving in front of you. So then the lifetime becomes extended. And this is how our warranties as well calculated. So we don't have a fixed number. We need always to understand how are the operation cycles, because based on that, dynamically, we are extending the lifetime and as well the warranty conditions to our customers.
Okay, next one from Xenia Reimer. 700 bar solution was reviewed. Are you planning to increase the pressure in CPV?
Not as of now. So I think the 700 bar was at that time a very brave step forward. I think that was I think it was very important to integrate this in the market at that time, which gives us as well a future compatibility even for the Mirai 1. So kind of future compatibility. But we don't have plans as of now, let's say, to increase the pressure or to go for cryogenics or whatsoever stuff. It could be in future if it makes sense. And on the other hand, we have to take care about how the, let's say, the vehicle becomes part of the functional safety of the refilling event. This is, I think, the critical part, what we need to define and agree on.
Okay, another one from Bernhard Albrecht. I saw an intercooler mentioned on one page. What are the thermal management requirements for such stack?
You have to imagine that nearly the same amount of heat you have as dissipation like electrical energy. And this is given by the PEM working principle. Yeah? So you're producing water, which you cannot move that amount of temperature out of it. So you really need to, let's say, actively cool it. And so this is nearly the same what you have basically in electrical power. So it's quite severe. It is a manifold of a typical combustion engine, because the combustion engine has the, in that sense, I'm a thermodynamic engineer, so the beauty of it of the combustion engine is that as your let's say with the gas flow, you can move out the temperature. as well. So not only by the cooling system. And this is, let's say, the advantage in that sense. So in a fuel cell module, we cannot move the heat out with the water what we are producing. It's not enough to move out. So we have to cool it. Yeah.
And a question that now it's the turn to tell Dr. C.T. Biedin everything where the fuel cells can be used, I can tell you, because the question of him, I guess, sorry if you are a she, but I think you're a him, a he, is it the Toyota fuel cell module suitable to other vehicles? For example, four-wheel drive, van, car, etc.
Yeah. So you have to think of, at the beginning, as I started the journey of the fuel cell module itself, I identified that, for many short trip and very light usage, a battery electric vehicle is completely okay. But if you think about to have a heavy load, you need a lot of torque. You need additional, let's say, power to cool something or to move something. There's many applications where, if you take battery electric buses at the beginning, the first generation, they had a diesel air conditioning system. So they had a very small diesel aggregate basically to supply the air conditioning because it was too much. So they could not use the battery for it because this would cut basically the driving distance. And this applies as well for many applications. If you think about road cleaning, vacuuming something, or lifting, or let's say as well for the Powell truck. If you operate it in, let's say, in a distribution service, very nice. But if somebody says, "Hey, we need a trailer, and you need to go now for the next hub," hello, you need to charge first before you can do that. In that case, you fill your hydrogen and go for it. You have exactly what you want to have. So this is a range extender, it's a power extender. And for that reason, you have what we have identified, nearly 40% of the typical applications, they will need this kind of additional power supply. Yeah.
Okay, so I think I cannot see in the Q&A section any more questions for now. Is there something that you want to ask Georg Zembacher? I can tell you in the meantime, if perhaps someone has got a question, what we are doing next week, because from now on, dear participants, I can tell you we will go ahead with the deep dive webinar series, and for the next time we will have it in cooperation with the Next Mobility Accelerator Consortium. And please have a look in the chat, next-mobility.eu. There you can find the consortium and you can learn all about they do have. It's a consortium from Shell, like you can see here. Shell, Paul Group, one of the largest retrofitters in Germany, and Meyer Koduletsch, and they will not only build trucks and stations and bring the hydrogen there, but also have a really fantastic model. It's a pay-per-use model. So if you are a logistics company or someone who needs medium-duty trucks, about 15 tons, then you should ask them to buy you some, and then you have the insurance in, you have the tank card, you have the pay-per-use model, so you are really reliable. And Constanze Weinkum is happy to get to inform you about the pay-per-use model. So this was the connection, now the bridge, why you are here, dear Georg, because just tell us a little about that. What are you doing there, and why are you related to Paul? What did you do for the trucks?
We are, let's say, in the truck, there will be the Toyota fuel cell module installed let's say, to be the second energy source beyond the battery. So as the payload increases or the operation needs to have a range extender, they will produce the electrical power for this beautiful truck. And this gives a huge flexibility for the customers to operate the truck 24/7. Because I think this is the major limitation of the battery electric vehicles. You have to charge. The charging time you need to consider. And in that sense, we can completely overcome this huge deficiency. So you don't need to think about the truck anymore. You have to think about how I get the next driver that can continuously operate and run the vehicle. So I think it's a beautiful fusion of the technologies, and we are very happy to be part of it.
There you go. Me too. And I just now posted you the direct contact to Constanze Weinkum into the chat, so you can easily click on it. And for sure also, no, you cannot click. Why can't you not click? We will have that done while I am reading the next question, and then you can really direct click on it in the chat. Benjamin Breuer is asking you, dear Georg, the estimated lifetime will, of course, demand on the cycles and power. But how high is the variation of lifetime or degradation of the stacks when used under similar conditions, power demands?
These are so many assumptions inside. We are typically simulating that very accurately, which gives us, let's say, from the fleet experience and degradation models, which we can really prognose that what will happen. So it is so difficult to explain or to answer this question as of now. So, but if you are, let's say, interested to get more information about it, or even you are really newly thinking about, hey, can we evaluate a potential packaging, or can we see if this technical data fits to us? Please reach out for me. We sign an NDA. It's very simple. Let's have a chat, and let's find out if this product could be suitable for your applications. Please.
There you go. And I can tell you, my team is telling me you cannot click directly on email addresses. Sorry, this is a new feature, but just copy paste it, and then you are hopefully happy, and she will give you the best solution here. There you go. And I can tell you, for this was what I wanted to tell you. Next week we will have Shell here. Dr. Carsten Wilbrand, he's a really good guy. Dear Georg, you told me, because you also had a look into the presentation that he did in June, and you just tell it in your own words, but you're really impressed, I guess. He will speak about sustainable heavy-duty transport from an energy system perspective. I think not only after February 24, we had this topic on our list, but for many, many years before, we are dealing with that. And I think he's a really good expert after your talk today, Georg, isn't he?
Yeah, Carsten is brilliant. You will have an insight what you have not imagined to see. And for me, this was eye-opening, because I thought, okay, hydrogen is hydrogen, but it's not like this. It's more complex. And if he opens the door, let's say, in the world of the complete infrastructure and transportation, and where to produce, how to produce, hey, you have a complete different picture combined with the, let's say, with the fleet operation. And for me, this was very surprising how mindful and how let's say, how difficult it is for an energy supplier and such a big corporation to make such a good job. So it is very, very interesting to see that. I could only let's say, promote it from my side, because it's really cool stuff.
And this is the partnerships that we are having in the hydrogen field, that we are exchanging a lot, and for sure we are doing that in the future. So as there is no question coming, I will again put your QR code now for the people right here, dear Georg, and I'm really happy when you meet us again, dear participants here of Hydrogen Moves, next week, same day, Thursday, same clock, same time, 4 o'clock European time. We will see each other again. And if you want to get into contact directly, perhaps next time we should bring the QR code also at the very beginning of the presentation. There it is, because we have to click through. Georg Zembacher, we have learned a lot, and thank you very much for TSUSHO NEXTY Electronics that they allowed you today to speak here with us, and I'm really happy to meet each other again.
Thank you very much.
Bye-bye.
Bye.